Hey everyone, how are you doing today? I'm gonna go over chemistry questions. C2 is tomorrow and it's gonna be just fine. One thing I'm gonna say really quickly is that there are overlaps between B2 and C2. Yes, thanks for joining me. Hi, oh, hello. Yeah, I actually wanted to do this by 6 o'clock today. I couldn't do it. Had a few things to sort out. I was just trying to get a few things, family stuff, just doing things. And then I just thought, you know what, I'll do it. I'll do it now. And by the way, I'm recording this as well. Although I'm live, I'm recording it. So what I want to do is I want to go over the C2 questions. I want to start with alkanes and alkenes. So yeah, there'll be lots that I'm gonna go over. So, but I'll just start with alkanes and alkenes. I don't know when you did it in your school, but it's part of the C2 questions for the AQA combined trilogy question. Okay, so that is alkanes and alkenes. Are you not gonna watch the alkanes and alkenes that I'm gonna do? Cause yeah. So I'm doing alkanes and alkenes, so I just use one stone to kill two birds. All right. So they are hydrocarbons, and you could be asked a single mark or 2 mark question to define hydrocarbons. Students sometimes make mistakes, so let's just avoid making the mistake. So hydrocarbons are, or they are made up of hydrogen, and carbon atoms only. I always write this in capital. Yeah, you need to remember that hydrocarbons are made up of hydrogen and carbon atoms only. Because if you have a structure like that, hydrogen and carbon only, this would be a hydrocarbon. But if you had Cl here, or if you had oxygen there, that is no longer a hydrocarbon, even though it contains hydrogen and hydrogen atoms and carbon atoms as well. It is no longer called a hydrocarbon. So I'm going to quickly whisk along to explain the difference between alkanes and alkenes. Basically, alkanes contain only single bond carbon. So all the carbons are bound to each other by single bonds in alkanes, but in alkenes, you have at least one double bond. So if you want to list the names of the alkanes and alkenes, you name them in terms of how many carbon atoms they have. So the number, whoa, so many of you have joined. Hello and welcome everyone. Yeah, how many carbon atoms that you have. So I'm going to start with the first one. So for alkanes, I'll do a quick table. So alkanes, alkanes, their names will be, this one starts with methane. So methane is CH4. All right. There is no methane because you must have at least one double bond between two carbon atoms. So this will start from ethene. So ethane is a two carbon alkane. So it will be two carbon atoms. So C, and then you have H around them. So it will be C2H4. C2H6 actually, because this is ethane. C2H6 because 1, 2, 3, 4, 5, 6. And ethane is, you have two carbon atoms and you have four hydrogen atoms. If you were to count, it would be 1, 2, 3, 4 for this carbon, 1, 2, 3, 4 for that carbon. So this is C2H4. That is ethane. That is the first form of alkane. So I'll just carry on with the other names. From ethene and ethane, you go to propane and propene. So this will be C3H8 and that's C3H6. And then you go to butane, and butene. So C4H, I think, oh no, that's 8, isn't it? Oh, that's 6. So butene will be C4H8. Why this will be C4H10. What I say to my students, when you're drawing this in exam, and if you ever forget that, you just do your counting quickly. Just go. If you were asked to write the formula for the 10th hydrocarbon, that is the 10th alkane, it will be C10. You already know it's C10. So you just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a formula, but in exam condition, just do that quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. See? So it will be C10H22 for an alkane. So, and remember, for that, there is always a there must be a one double bond between two carbon atoms. The main reason I usually just do the first 4 is because when you go beyond the 4th hydrocarbon, you just work it out the same way you work out your polygons in maths. So if you remember your polygons in maths from pentagon, or pentagon, yeah, I think this, I'll spell it first of all. Pentagon is a five-sided polygon. The same way you can use that to name your hydrocarbons. So pentane is C5 and H12. So, and then you go on to the next one here will be pentene, and then you go hexane, and hexane, you go octane, and you go nonane, and decane. Just exactly the same way you name your polygons in maths. And obviously, like I just showed you, can work it out. Another common question, it might just be a 2 marker, but it's 2 marks that you don't want to lose. All right, so very simple question is the bromine water test. The bromine water test for alkanes and alkenes. Now, alkanes are said to be saturated. I'm going to explain that. They are said to be saturated hydrocarbons, and alkenes are unsaturated. Alkenes are unsaturated. Very simple. What this means is that this is full. Hydrogen, from your bonding, when you did periodic table and atomic structure, carbon can take up to 4 bonds around it, and it will be full. There is no more there's no more space to bond onto. If you look at in the case of so that means that each carbon atom in alkane is satisfied, is saturated, as it were. It is full, right? When you then go to alkenes, on the other hand, because there is a double bond, it means that can react with other substances, other elements. So this is unsaturated, it is not full. So if you have ethene, for instance, H, and you have your H, you have your H, and you have your H, it means that in a reaction, this double bond can be broken, and then you end up with what looks like this. This is your H, that's your H is here, and your H is here. If you look at that, carbon can take up to 4 bonds around it, which means you have a space here. There is a space here to add on to. There's a space here to add on to. So for the bromine water test, there is no reaction here. Alkanes do not react with bromine water. They remain unchanged. But in the case of alkenes, there is a change, because the color of bromine water is brown. Brown bromine with alkenes bleaches, colorless. That is the bromine water test. So alkanes will react with bromine water, and they will change the color from brown to clear or to colorless. That's the bromine water test. All right, and it's only alkenes that have this reaction. That's why for those of you that are doing higher, your polymerization also comes here. it is, that's why alkenes is able to form polymers, because you can bring several ethenes together, break the double bonds, and rejoin them together under very high temperature and pressure, and you have polyethene. So that is how monomers of ethenes are joined, which are ethenes are joined together to form a large molecule, which is called a polymer. All right, that is how that is done. Okay, I've explained that. The next thing I want to quickly explain is water purification. So they could ask you to explain the steps involved in the purification of water, and this will be your response. I've put it up here. I don't know how many of you can see it. Water treatment, the stages in water treatment. They could give you a water source or ask you to choose a water source. Now, if that happens, this is what you've got to do. So if you take your sewage water, so this is water purification. Your sewage water, the first thing is filtration. Now, what happens? You need to be able to explain, because if they ask you this as a 6-mark question, you are good, because it's so easy to remember the steps and to explain. You've been doing filtration from year 7, if not from primary school. All right? So this is what I need to explain to you, remind you of. So filtration is to get rid of the large lumps. Okay? The large lumps or the large particles. Then you go on to sedimentation. It's a big word, but honestly, it's just to form sediments. So there will be some particles that cannot filter off. You let them settle. So it's just, you leave the liquid, as it were, and you allow it to settle. You know that if you have dirty water or water that's got some particles that are tiny, when you let it settle and stand for some time, the particles that are very small will form a sediment at the bottom, and then you can pour off the clear top liquid that you want to further purify. That's done in the sedimentation tank, and then it goes to the fine filter. Now you have the fine filter. Okay, so you have a fine filtering system here. So you end up with your water that still got particles in it, but this time around you cannot see it with your physical eyes. So you may have some contamination, so you may have some bacteria in it, you may have something that can harm you. And the best thing to do to lock those microorganisms that you cannot see is to get rid of them. And that process is the process of chlorination or sterilization. So chlorination is what hang on, I'm going to spell this right. Chlorination. All right. Chlorination is the process of adding chlorine to it. Some of you already know that chlorine is a water purifier. This is how it is done. So this is done to kill off or to remove all the other particles that cannot be seen with the ordinary eyes. Now, when you've done chlorination, there could still be a chance that there are still some sediment, or sorry, not sediment this time around. Your water is clear enough to the ordinary eyes, but there could be still some microorganisms or some other harmful substances, and then you do boiling, which is actually the process of distillation, because distillation involves boiling and evaporation and condensation. So the last stage in that process will be distillation, double L. All right, distillation. Now, distillation is done in a fractionating, not fractionating tower. That is fractional distillation for crude oil. Now, distillation is done in a distiller apparatus. So the apparatus, you have a place where when you heat up your liquid, right, you apply heat to your liquid, right, and it starts to boil. Now, when water boils at 100 degrees Celsius. At that point, when it is boiling, it would have killed off all the bacteria that is left there, and then the water that comes here as vapor goes through the process of condensation. All right. and then your liquid water is collected in a jar. Someone just asked if this was higher or foundation. This is for, I'm focusing on foundation, but there are higher aspects. And if you've been following the AQA paper, there has been a lot of foundation stuff that has been on the higher paper. Because remember, foundation is actually a higher paper is actually foundation and a bit more. So my focus is young people who have been struggling all through the year, and they now want to write the foundation paper. They just want a 5, to just get the GCSE, because otherwise they think they're going to fail. Those are the ones I actually encourage, because people doing higher, by now you should be okay to write your paper and get a 7. So what you pick up from my revision section, I hope would help you to find questions that you may have overlooked whilst you were concentrating on the more harder stuff. All right. So if you need a 4 or 5, then you're welcome on board. You're the sort of students that I live for. You're the ones I do my videos for. Because for the higher students, they should be ready, because higher students should have already been prepared for this exam by now. But if you're just looking for lastminute.com revision to help you still get a 5, 4 or 5, then you're in the best place that you should be. So that is my focus. So that's why I emphasize the things that that are like everyday occurrences, or things you can easily remember. These things are so easy to remember, and I have proof that I've been doing this for years and it works. Okay, so that's just to explain that. All right. Now, the next thing I want to just remind you of, there are questions from C1. The topics in C1 that you will find on paper 2 are the atomic structure, periodic table, ionic bonding questions, and ionic bonding, covalent bonding. All right. Covalent bonding, you need to remember the characteristics of these structures, and then quantitative chemistry. These are the topic, C1 topics that could be on your paper as well. All right, so I've explained all of those, and I'm going to go on to I'm going to go on to another question. This paper that I've put here just reminds you of some questions which I covered when I did the C1 revision, and they are like, what is conservation of mass? How do you use concentration formula for calculating? And I put a few of the calculation there. And I say you must convert. Remember to do your conversion. If you're given a question, this is actually focusing on higher there. All right. If you want to remind yourself of the calculation, how to calculate relative formula mass, atomic mass will be given to you, and how to do all of those calculations. Those are topics from C1, which are covered still in C2. I have a series of my questions which I am going through. Okay, so I have some more here which I'm going to put up. These are some more calculations. I'm telling the person videoing to just focus on them for a bit if you need a reminder. Those are some of the C1 questions that could be on the C2 paper. All right, now it says explain how when a metal now it says when a metal corrodes, or when a metal is covered by rust, how does it affect conductivity of the metal? Conductivity will decrease because an ionic compound is formed which will not conduct electricity when it is a solid. I just found that question, and I thought on the AQA Kibodo website, and I thought to myself, I am going to pop it there because it could just be on your paper. And then it says you should compare the properties of graphite and copper. Now, graphite conducts electricity. It is soft, it is slippery, it is brittle, it has a high melting point. And then when you look at the copper properties, Copper can be bent or malleable. It's easy to bend it. It is ductile, or it can be shaped into wires. It is strong. It is not soft or brittle. It conducts electricity. It has a high melting point. When you put these properties of copper together and that of graphite, you can come to a conclusion that in that situation, copper is a more suitable material for creating electrical cables. All right. And it says for iodine, iodine is in group 7. And if you draw the complete diagram of iodine, how come the outer, he says, when you complete the diagram below, an iodine atom reacting with another iodine atom forming a covalent bond, he says you should show the outer electrons only on how the bonding of iodine works. All right, how it would look like. I saw that question and I thought I'll pull it up as well. It might just be on the paper. These are the areas of C2 that I was looking at. This is a full checklist. All right. So now there are particles. You know, when iodine liquid is when iodine is a liquid form, it does not. When iodine is not in a liquid form, it does not conduct electricity. Yeah. So it cannot conduct electricity as anything that's a solid cannot conduct electricity. It must have free flowing electrons for anything to be able to conduct electricity. All right. And then there was a question about people not having enough food in their enough iodine in their diet, and how does it affect people. Now, the way iodine affects people is that where there's actually no sufficient evidence that it actually affects people deeply. So it's an ethical issue. If people want to have some more of the iodine in their diet, they could, if they want it to affect, if they think it could affect them. I don't know if you can see that diagram. That would be how you would do the covalent bonding for two iodine atoms forming an iodine molecule. Remember, when you write it with a sub-2, it forms a molecule, and that is how you can write it. All right, I'm just going through quickly. I have some questions that I want to emphasize. The diagram for distillation that I was talking about earlier is that. So you have a thermometer to measure the temperature. You have the column. This is the column. And then you have your conical flask where you have a mixture of different alcohols if you're trying to separate different alcohols. And then you have that evaporation is happening there because you have applied heat. And what is coming out here is actually the alcohol that you want to bring out. You want actually separate. I want to explain something about the distillation. There's something I always say to my students to remember. When you find this outlet and that outlet, remember why they put it on the distillation column. It is because water needs to be let in. When you let in water, water cools down and enables condensation to happen very, very quickly. All right. I told you I was rushing so I could get to some point. The point I want to get to is the required practical reaction of sodium thiosulfate with acid. I don't know how many of you remember that practical. So it's called the disappearing cross practical. That's a required practical, the disappearing cross. So that is a required practical for C2. And another practical is reaction of hydrochloric acid, or they could give you a different acid, hydrochloric acid with Mabushii. Okay, I feel strongly about the required practical. The reason, whether I feel strongly or not, I do feel strongly about them. They are called required practical for a purpose. The reason they're called, you're not going to fail, you're going to be all right. The reason they're, Justin, you're going to be fine. The reason they're called required practical is because you have a very high chance that they will ask the question about the practical in the exam. So I am going to explain it to you. Now, if you remember that experiment, you did it by your teacher marking a cross on a piece of paper and placing a beaker on top of it. A clear beaker placed on top of that cross. When you look through the beaker, you can clearly see the cross. All right? Now, what your teacher would then do, they will put in the two liquids into it. What they actually do, they will put in your sodium thiosulfate. Let me write it so that you remember how to. So your sodium thiosulfate, and they need a timer. Very important in this experiment, because that's actually what you're recording. You're recording the time in seconds, how quickly the cross disappears. So I'm just going to explain it first. So when they measure your acid into this container, they will then pour in the sodium, a certain volume of sodium thiosulfate. Now, when they pour in the sodium thiosulfate, the cross will gradually disappear. What makes the cross to disappear is because a precipitate forms. Now, a precipitate is formed when you mix together two liquids that are actually immiscible. Well, they mix to an extent, but they're not totally immiscible. They form a precipitate. A precipitate is actually a soft solid, a very soft, tiny, layered solid. A bit like when you do the test for carbon dioxide. If you bubble CO2 through lime water, it changes from clear to cloudy. Actually, that is a precipitate. When you do the food test when you use the ethanol to do the food test for fats in B1, when you do that test, what actually forms, when it forms a whitish coloration, an emulsion, it is actually a precipitate. So those are examples of precipitate. So in this instance, a precipitate is formed. So what you do, you record the time, and then you put another level of concentration of acid. So let's say you started with, you want to do 3 different types of acid. You use a very weak acid. You use a very weak acid. Now, when you use that weak acid, it might take 10 minutes for the cross to disappear. That means you can't see it anymore. It's blanked out. I see so many people joining. Well done and welcome. All right. Now, you might want to use a slightly more concentrated acid, right? Then say it might take 5 minutes for the cross to disappear. See, that is getting short at the time. You might then take a strong acid. You might then take a strong acid, which might take 1 minute or 30 seconds. Now, in writing your conclusion, you would conclude that the more concentrated the acid is, the quicker the cross disappears. So the quicker the rate of reaction, because this is testing concentration. There is one way of testing the concentration affect the rate of reaction. So that is how you draw your conclusion, and that is a required practical. Remember all the precautions you need to take. Remember that you have to measure a fixed volume of acid, fixed volume of sodium thiosulfate. It is the concentration that is your independent variable. The time that you're measuring is your dependent variable. Your constant will be the volume of acid, and remember all your safety goggles. This is acid your safety goggles and other safety measures. Now, that is the first required practical I wanted to talk about. The second required practical I want to talk about is the reaction between hydrochloric acid and Mabushii. Again, it can be about different concentrations. So let's say you measure out these concentration of acid that you want to use for your practical. A few things you must remember. Now, you're measuring the amount of CO2. CO2 is a gas. AQA might outline the practical and ask you to correct it. They're good like that. EDSL usually would tell you to talk about the practical. But, in whichever way, the exam board, we don't know. It's a new GCSE. We don't know what they're doing this year. However, if they ask you to outline it, it will be a 6 marker. These are your key points. These are the things you want to remember. It is a gas. The best way to collect a gas in any experiment is to use a syringe. All right? Is to use a glass syringe or a gas syringe. Key point number 1. You must use a syringe to collect the gas. The reason is because there is no chance of escape. So you have a more accurate result of your reaction. Okay, so that's what you use. Now, when you select different concentration of acid, you must then keep the size of the marble chip constant. So maybe you just use say 0.2 gram of marble chip for this experiment. So which means you measure out your acid, you drop your marble chip in it, you use a timer, your time must be fixed. Let's say you allow it to run for 2 minutes. Now that is a constant as well. The size is a constant. This is your independent variable. So this is what you're changing. All right. And then for each one, you record how long it took for, or how much you measure how much gas was produced. I can assure you, if you collected, say, 2 centimeters cube of 2 centimeters cube 2 centimeters cube of carbon dioxide at this concentration, you might double or triple, and the more you go, the more it should increase. Something just popped up in my head right now. Another thing you need to remember about practical is the anomalous point. They might show you a set of results and there will be one that's off. That's your anomalous point. Remember to plot it on your graph. Remember to identify the point that's not in line. And when you draw your line of best fit, do not freak out about your anomalous point. Just draw a free line of best fit, and whichever point does not fit in, well, tough. That's an anomalous point. That just popped up to my head. I thought I'll mention it. So you do this. So another thing to remember, if they've written the practical and ask you to correct it or improve it, remember to repeat this. So do each concentration 3 times and take an average. That way, remember this is GCSE, don't use the word fair test. You get more accurate result. Yeah? Remember, we're talking proper scientific talks now in GCSEs. Lol, proper scientific talk. Anyway, so you do that for each concentration and you take an average and you'll be able to get cell results that you can use for your graph. Now, this is also concentration, this is time. But another way to improve it, if the exam board has explained everything I just explained to you, another way you could do this practical, because they could outline everything I've just said, and you go, oh, how does that help me? How will I know how to improve it? You can work on the marble chip. So you can have a marble chip that's whole, yeah, a lump. You can just have a lump. And then you have another one crushed up a bit. And then you can either have a set that's fine powdered, grounded to powder. Now, when you do this, the particular factor of rate of reaction that you're checking is surface area. All right, is surface area. Please don't get yourself mixed up. If you grind it to powder, you are increasing the surface area. Because if you have a lump, I'll just explain it with a diagram. If you have a lump where the acid can touch it like this every minute at 4 points, for instance, but if you break it up into pieces like so, then the acid is touching it, yeah? Just imagine how many times, 16 times in that same minute. So the reaction is faster because you increase the surface area. So this is testing the surface area. Again, your time has to be fixed. So if you put it with the lump, you time it. When you're timing it, and now another way you know that the reaction is completed, because you're no longer collecting the volume of acid, you are observing how long it takes for the reaction to stop. The way you will know a reaction has started, it starts to fizz because the gas is giving off. Once it stops fizzing, you know that the reaction is over. It has stopped. It has stopped reacting. All right. So say with the lump, it stopped reacting after 2 minutes, say, or 12 minutes. When you crush it up, it might stop reacting just after 8 minutes. With the powdered one, it might just be 2 minutes. So the time is reducing, the rate of reaction is faster. By the way, the rate of reaction is how quickly a reaction goes into completion from start to finish, the time it takes. So that is the rate of reaction. So these are the factors. So I've looked at concentration, I've looked at surface area. The other factors are temperature. Remember when we did the salt, making salt? Oh, okay, actually in this experiment is relevant as well. Another way you could improve it, if they say to you that the person used cold acid, you might want to heat it up. Because when you increase the acid of the when you increase the temperature of the acid, you kind of give energy to the particles. Not you kind of, you actually give energy to the particles. And the more the particles have energy, the more they bump into each other. Therefore, the rate of reaction is faster. So I've listed three: concentration, that's having more surface area, breaking it up to increase the surface area. And then I've talked about temperature. The last one is the use of a catalyst. Okay, when you use a catalyst speeds up the rate of reaction. Enzymes are biological catalysts, so they're kind of like enzymes. Some of the catalysts you can use is you can use copper oxide, you can use manganese oxide. These in this instance, they do not take part in the reaction. They only help to speed up the rate of reaction. Now, if you're talking about the Haber process, we used to have a topic, Haber process, that's the production of ammonia. We needed to talk about the pressure. I want to just mention it because some people might understand that that pressure is also a factor that affects the rate of reaction. Because some people just joined, I'm not going to go over everything I've said. Just to reiterate, the factors that affect the rate of reaction are temperature, concentration of the reacting particles or reactants, the surface area, and the use of a catalyst. I also added the pressure. Okay, because in terms of pressure, when you push the particles closer to each other, you bring them to close proximity and they're able to react faster. That is how pressure affects the rate of reaction. So I have just gone over those two required practicals. Like I said, I feel quite strongly about them and watch out for them. Okay, I'm looking at this question. All right, carbon footprints. I want to look at carbon footprints before I look at I don't want to forget. So I don't forget, I'm going to come to carbon footprints. I just remember cracking. That was the last thing I did in class today with my students. If they are watching, they will remember. Those of them that were listening, they were lovely. My year 11s, they're awesome. I know they're going to make all of us proud. And so you guys, if you've been following, I'm so looking forward to your result. I know it's going to be good. All right, so cracking. Now, when a country gets its crude oil, or countries, when they go and buy crude oil or they refine their crude oil, now crude oil is a mixture of different substances. So you can get gas that's used for cooking, you can get petrol, you can get diesel, you can get bitumen, you can get paraffin. However, the lighter hydrocarbons like petrol and diesel are usually in higher demand, but usually they're never enough. I think it's because the demand is so high. So these days, the 21st century population are so dependent on petrol and diesel that countries never get enough from the crude oil that is refined. But they end up with a lot of bitumen and other hydrocarbons that they don't need. So what scientists have come up with is to break up those long chains. So if you have a 24-chain hydrocarbon that you don't need, you can use cracking to break them up. Use cracking to break them up to give you the shorter chain. So let's say you need 14 carbon hydrocarbon, your petrol or things like that. You break up the long chain hydrocarbon into smaller ones that you have in higher demand. Yes, cracking is hydrocarbon. Yeah, that is how cracking helps countries or government government to get more out of their crude oil, because they don't need those long chain ones and they're in huge amount. What's the point? They crack them up. A student was also talking about fracking. That is different. That's different. That's getting crude oil from animals, sea animals and things like that, from other sources, not from crude oil itself. It's a major issue of debate. All right, so I've looked at that because I did not want to forget that, because I don't actually have it in my notes. So I want to look at carbon footprint. Carbon footprint is just a mark that represents, it's a definition of how much carbon you are producing by your lifestyle. Yeah? So is a definite word that defines how much you are adding to the carbon that goes into the atmosphere overall by your life activities. All right, that's it would be indicate your carbon footprint. And now, whilst they might not ask for a definition, they'll definitely ask for the impact. Yeah, on the specification is there the impact of the carbon, how to reduce it. Now, very simple. A change of lifestyle, change of ways of doing things. For example, people can choose to walk to take a walk rather than ride in a car. People can decide to take a bus or train for regular journeys, and people can decide to bike or cycle, however you want to put it. And people can decide to just turn off their lights, put a jumper on in the heater rather than in the winter, rather than put the heating on, then change to solar panels and things like that. Use more renewable energy resources rather than depending so much on electricity. One of the ones my students said today, use eco cars, yeah, and then reuse rather than recycle. Because I know recycling is good, but energy is still used in the process of recycling. So it's actually better to reuse, because when you reuse, there's less waste produced and there's less burning, there's less fuels or fossil fuels being used to recycle them and all the other processes that are involved with that. So now I want to explain something very, very important again. I'm going to write some keywords on the board. It could come up as a 6-mark question. I'm always interested in 6-mark question because I don't want anyone to flip over a 6-mark question, because you need it. You need those 6 marks, and it's easy. Remember what I told you. Read the question, read it again, highlight all the keywords, and begin to explain that. Before you write your final one, do a quick draft. Do a quick draft of your point and say to yourself, do I need to rearrange this one? Sketch little diagrams you need if you need to. Yes, someone said cracking is thermal decomposition of alkanes. Yes, that's the definition. I had to explain what it actually means. Yeah, you are right. Okay, so I'm going to list some words here. The words I want to list are: 1, sulfur dioxide, carbon monoxide, soot is another one. And what's the other one? NOx. Do you even know what that is? And how do these impact on the environment? Now, sulfur, when fossil fuels are burnt, sulfur is given off. Now, sulfur reacts with oxygen. Sulfur reacts with oxygen to give sulfur dioxide. Okay, that is how it is formed. How is it? How does it impact the environment? Sulfur dioxide mixes it with water. They will mix with water in the atmosphere and fall as acid rain. All right. While we are here, I'm just going to explain NOx. Now, nitrogen oxide can react with nitric oxide to form NOx. They form a substance called NOx. NOx can then form smog. Yeah, smog is a mixture of nitrogen oxide and nitric oxide, and that smog is a part of the problem that causes acid rain. Now, acid rain can destroy aquatic life. It can destroy buildings, can cause buildings to wear away. Depends on what material they're made from, and that will cost money to repair. Yeah, and some people have reported that who lived in very highly polluted area, that they had some skin problems. I don't know how far that has been established, but the one I know is it causes harm to aquatic plants and animals. All right, and it damages buildings. So that is those two. So I am left with carbon monoxide and soot. Soot is very quick. Soot is smoke that has settled. Very simple. Yeah. And it can discolor places. It can cause breathing problems. It can make asthma. Smooth and smoke, I'll put them together. It can make asthmatic patients suffer a lot. Okay, now I'm going to talk about carbon monoxide because this is also in cigarette smoke. Those of you who smoke, watch out, you need to try and stop. Okay, I know it's hard, but you can do it. It's possible. All right. Now, carbon monoxide is formed due to incomplete combustion. So combustion in cars, for example, combustion not completed or incomplete combustion leads to the formation of carbon monoxide. In full combustion under full oxygen, that leads to the production of CO2. Carbon dioxide in itself is a harmless gas, although when it builds up in the environment, it is a greenhouse gas along with methane. They're greenhouse gases, and they contribute to global warming overall because they trap heat in the atmosphere and radiate heat back on the earth, therefore raising the overall temperature of the Earth's atmosphere. And you know the downside to that, it can cause ice caps to start to melt. And when that happens, they'll flow into water bodies like oceans and rivers and cause them to break their banks and cause flooding. Flip it to the other end, it can also result in drought. Like I was saying in class today, drought has serious effect on the population because where there is drought, it means that there is no sufficient rainfall for plants to grow. And if plants do not grow, animals will not have food. If animals don't have food, you're not going to get KFC chicken. You're not going to get meat. You're not going to get milk. Humans will suffer as well, and things like that. And things like that. You're laughing your head off, all right? Well, but you get what I mean. So there'll be food shortage. In, there'll be food shortage during drought. All right. So what was that on about? So incomplete combustion leads to carbon monoxide. Now the major problem of carbon monoxide, wait for it, carbon monoxide takes the place of oxygen. So carbon monoxide displaces the oxygen in blood hemoglobin, displaces oxygen. There you go. People doing higher. I'm using massive keywords now. You break it down. Displaces oxygen in blood. If you're doing foundation, stop there. If you're doing higher, you can add hemoglobin. You don't require it for exam. That's just me having a quick laugh, a little laugh there. Yeah, blood hemoglobin. Hemoglobin is just what makes your red blood cells red. Basically, it's a pigment, but it is also what binds oxygen. More importantly than coloring your blood cells, it is what binds the oxygen. Now, if you have carbon monoxide will take the place of oxygen, and that can cause breathing problems. If it's in large quantity, it is lethal. It is deadly. There are people who have died, whole families have died because of the level of carbon monoxide that they inhaled. They became breathless and they died. So it is a terrible thing to have in the air, an atmosphere around you. I think I'm nearly done with what I have written here. All right. So finite resources are resources that will run out. Resources like our what do you call it? Crude oil, coal, gas. These are fossil fuels. They are finite. They are not forever. They will one day run out. Unlike the renewable energy resources, which will always be there. If you take more, it replenishes itself. Water, solar power, all of these other energy resources that are renewable. Non-renewable energy resources or finite resources, if you keep taking on them, it will one day run out, and it could lead to several problems. People could suffer in several ways, and their government could begin to struggle, and they could also lead to pollution. Then there is a key phrase here: what is sustainable development? I need to write that and talk about that because that's actually a course you can study at the university. That is how important it is. Sustainable development. Okay. Now, there is nothing that the government can do about development. As a matter of fact, development is good. When I was your age taking GCSEs, we didn't have mobile phones. Life is so much better with mobile phones these days. It's technological advancement. So development is a positive thing. But when you want to have sustainable development, is you need to maintain, you need to ensure that as you're taking out of the finite resources, you are making effort to replenish it. A very simple one that comes in my mind are the rules and regulations that the UK and other advanced governments of the world have in place for cutting off trees, for example. Deforestation is a devastating problem. Deforestation takes away, why I don't want to go into B2, but deforestation, suffice to say, in a short way, disastrous. Now, government of the world, where civilized part of the world, they put in rules and regulations in place such that companies that are cutting down trees for one thing or the other have plans in place to replant. In my country of origin, Nigeria, for example, there was a rule that went out, an advert, and people, it was all over the news. You were, when you cut down one tree, you plant two. It was for every one tree you plant two. I'm not quite sure the rule in the UK, but there are rules like that. There are rules that govern fishing. You can't just go anywhere and fish. And there are, even in areas where you're allowed to fish, there are rules that govern the time, because they don't want you to go in the breeding season where you capture all the females with eggs. That way, as a particular species could go into extinction. So government have those rules in place, and government make companies that are making money from a country responsible for ensuring the conservation of resources. So they have to make their fuel safe. They have to lower the level of sulfur in their fuel. They have to make sure that car manufacturing companies have to make cars with catalytic converters. That's another one. Catalytic converter put into the exhaust converts or breaks down these gases that we talked about, the sulfur dioxide and carbon monoxide and all of that. They convert them into the safe gases that can be returned back into the atmosphere so that your car engine burns cleanly. That's why new cars in the UK for the first 3 years they don't pay road tax, because their engines are efficient, they burn cleanly, and eco cars are more encouraged by the government and other organizations because they use less fuels. It's all about sustainable development. So on the one hand, development is going on. However, we are ensuring that we are not using that to get rid of everything and leaving us or leaving the next generation to suffer. All right. Okay, so that is what I can just tell you about sustainable development. So ways of doing that I have talked about soon. So that is why, for example, in the case of mining and quarry, another thing I forgot to say, before wind turbines and things are just put in areas, there is consultation, because the people have to be consulted and things have to be done the proper way so that lives are habitats are not just destroyed and people's lives are not endangered. We do need the development, but it has to be sustainable, it has to be safe, and it has to be the one that carries on, not just the one that you start and it runs. I know it needs to carry on. Who said stop shouting? I don't know, I'm shouting. Well, my voice is loud. Maybe it's not me. Are they talking to each other? Well, I just want to be loud enough. I'm naturally loud. I'm trying to look at, I think I have, okay, explain the benefits of recycling or reusing metals and glass and plastics. All right. When you when you recycle metals and glass and plastics, it is because you don't then go and mine for fresh metals, because metals come in their ore, that is they are found with other materials in the earth, in the land, in the ground, and you can quarry for them or you can mine them. But if you recycle the ones you have rather than throw them away, you will not need to go and mine fresh ones again. All right, I have gone through nearly everything. Okay, the last section I want to go through is the Earth's early atmosphere and what we have now. So in the current atmosphere, these are the raw values of oxygen that we have. Nitrogen is 80%, carbon dioxide is less than less than 1%, and you have other gases as well in the today's atmosphere. However, in the beginning, it was not so. So what scientists have told us is that in the Earth's early atmosphere, it was mainly covered from the Big Bang. It was mainly covered with large methane gas and CO2. So there was a large amount of methane and CO2. Now, this is a little journey. If you understand, all right. So if you the methane and CO2, right? If you what do you call it? If you have CO2 or the early atmosphere had CO2, now what happened was there was evolution or microscopic plants, microscopic plants evolved, and they use the CO2 for photosynthesis. Those of you that are following, please, this could be a 6-mark question. All right, this could be a 6-mark question, and you can use these points to answer the 6-mark question. Okay, so they use it for photosynthesis, and remember, the process of photosynthesis is CO2 plus H2O to give out oxygen, and glucose obviously is to make glucose. Glucose is 6,6H12O6 if anybody is interested, but glucose, that's the formula. All right, now this oxygen became relevant and important for plants to uh, respire. So this also enable sorry, not plants respire, but this made animals. So microscopic, my pen. All right, so microscopic animals, yeah, microscopic microscopic animals also evolved, and you know what? They were able to use the oxygen for respiration. Okay, they were able to use it for respiration. All right. Now, as a result of that respiration, what happens was with that, the amount of CO2 began to reduce. Another thing about the CO2 is that, remember, there was also water vapor. There was also water vapor in the early atmosphere. That water vapor, scientists tell us, they condensed. So the process of condensation led to oceans, all right? And now these oceans, these oceans were then where you find some of the CO2. The CO2 dissolved in the oceans, and animals and plants that were on the ocean, when they died, the CO2 that was in their body and the one that was locked away in the ocean, they eventually formed crude oil or fossil fuels. And you know, when you burn fossil fuels, when you burn fossil fuels, you give off or you release the carbon that's inside them, that's locked into them. Okay, that is what I have written here, and I have covered it, and I hope I hope that you have actually picked one or two things. I do this for people who are willing to learn and to improve their lives, and I am very excited. I am very happy. I'm very pleased with all of the comments. All right, I am very happy with all of the comments, and absolutely, I know you're gonna do well. You take care, and God bless you. All right. Bye and God bless.